Hello everyone, my name is Galen Helms. I'm going to be your presenter today. Today's lab is electric field and flux. So what is an electric field? An electric field is a region around a charged particle or object within which a force would be exerted on another charged particle or object. We represent an electric field using field lines. Just think about it this way. If we were to take a charged particle and release it beside one of these other charged particles, it would want to accelerate one direction or another. So what are field lines? Field lines show lines of force. The strength of the field is also shown by the number of lines that we use. Here is a very, very weak field. Here is a strong field. Just by convention, we say that positive charges emit field lines, so the arrows point out. Negative charges receive the field, so the arrows point in. Some examples of this would be, here we have a positive and a negative charge. You can see the field goes from positive to negative, all the way around, all the way around. Here we have a couple of charged plates with a uniform field inside. Notice the field lines are equidistant apart. Here we have two positive charges, and notice how the lines never ever touch each other. Another thing about some of these pictures are here, we have these little circles, this line here, we have these lines. Those are called equal potential lines, and those are something we're going to talk about next week. Next, we're going to show a quick little demonstration of what fields can look like. This is actually a magnetic field, but visually it can be very, very similar to what an electric field looks like. Okay, here we have some iron filings suspended in some kind of a very thick liquid. And what I'm going to do is when I insert this magnet, you'll see that the filings start to move together, and they move into what would be the magnetic field lines. Now those field lines, even though this is a magnetic field, the visual is going to be very similar to what an electric field would look like whenever the filings, if they could, conform to those lines. Okay, for the last part of our little lecture here, we're going to talk about electric flux. Electric flux is probably what this lab is mostly about. It's defined as the amount of field that goes through a specific area. So here we have our field lines, and here we have an area. You see the lines passing through that area. Our flux is defined as EA cosine theta, where E is the electric field vector, A is the area vector. There's also cosine theta. Theta is the angle between the electric field and the area vectors. So what is the area vector? That is something you guys may not have seen before. The area vector is always perpendicular to the area, and then the length is proportional to the area. So a tiny little area will have a small vector, a larger area will have a larger vector. Now, for the lab, we need to put those two together. Here we have a full-size flux, where we have a large area and a very, very large field. And if we have a smaller area, a weaker field, or greater theta, it will reduce the amount of flux that is seen by the area. So here is a full size. Here is a smaller area inside the same field. Here is the same area, but in a much weaker field. Or here is in the larger area in strong field, but you can see the angles, there's a large angle in between. And that will conclude today's lecture. Thank you very much.